All right, so this looks like there's a lot in here, and there are. Like I said, this is why you need to make sure that you do this ahead of time. Your lab time will be so much faster. Also, doing everything ahead of time. You do need to make sure you show your work. You will be taking a picture of, this is table C. It got cut off, but it's table C. You'll be taking a picture of table C before you come to lab, and both pages of table C need to be in the picture, like it be a PDF that has both of them, something like that. You'll be uploading that to your lab quiz. And again, like I said, you have to have the work showing, and it's and that's a part of the lab quiz right there. So for all of these, you have to have the lab work showing. So this is what we're going to do. And again, a lot of the questions on the lab quiz are directly from these charts. So it's kind of a twofer. The first thing you're going to do is look at NaF, or whichever compound you have, and you're going to write it as its positive and negative ions. So like in this example, you would be writing like NH4 plus, and you'd be writing Cl minus. You're going to react them both with water. Make sure that the plus is getting an OH group, and that the minus is getting an H plus. H plus. And so you can see over here, that gives me HF, and what's left over of the water is an OH group on this top one. When it gets NaOH, this is what's left over. But remember, then what you do is you look at your products. If it's a strong base or a strong acid, it will not stay together in water. It has no intention of making this compound because it prefers to be separated. There's no energy that will hold that compound together. This is not a strong acid or a strong base, and so it does stay together. As a reminder, if you can't remember, here are our strong acids: HCl, HBr, HI, and then H2SO4, HNO3, and HClO4. So if you make any of those in the acid form, the reaction will not happen. You need to cross it out. The strong bases, it's the alkali metal column, and so that's the Na, and it goes down, like there's potassium, and it goes all the way down to like cesium with an OH group. They're +1, that's why they only need one OH group, as well as the alkaline, starting midway, so starting at Ca and going down. Notice that because it's a +2, you're going to need 2 of them. So that's the first part, is filling this. There are either 1 or 2 questions where you're just picking the correct set of equations and also figuring out if it's acidic or basic. Notice that if you make an OH group, you're going to be basic. If this was the one you had crossed out and this was the one that you had kept, then you would say it was acidic. So keep that in mind too. Like I said, like 2 questions or so are just the list of reactions and you deciding if it's basic or if it's acidic. Then you're going to write the K expression. Now, we know that this is Kb. Again, we knew that it was basic, but we know it's Kb because it has an OH group in it. Also, you're going to actually be writing the products that are in the equation as it's written. And so we have an OH group on top. So here's our OH group on top. It's this one right here. We have an HF group over here. And then it's just divided by our F minus section right over here. That's our K expression. Now you're going to look on Appendix H or I, and note there's one of these that isn't in the Appendix H or I, but if you look at the lab has an Appendix H link, it has an Appendix I link, and then it also says it's like the missing Kb value. So the third one down, you're going to be able to find the one that's missing. So like I said, they're each links in this lab so that you can get to them really easily. And the reason we're looking this up is because you won't be able to find the Kb for F minus. You'll try, and you're definitely welcome to look up the Kb for it, but you won't be able to find it. And so the only one that you can find is the one that matches HF, but notice it's in the wrong position. This is not an HF reaction. The way an HF would look is it'd be HF plus the water, and then it'd be donating its H, and so you'd be making H3O plus and F minus. So you can tell that that's not the reaction that's going on here. You're making OH because you already said it was basic. Salts all do this where they do this flipperoo thing. So you're going to write the relevant K value. You're going to write the relevant K expression. And then on the third column, you're going to convert it. So all of this column will be done the exact same way, where you're doing the 1 times 10 to the minus 14th divided by the whatever the K value is. Just make sure that, like the NH4 K values will be different than the than the F minus K values. So just make sure that you aren't keeping the same K value for each one, but it's the same exact, like the math for it. It's 1 times 10 to the minus 14th divided by 6.4 times 10 to the minus 4. And here's our number. Now, you're also going to go ahead and write the ice chart. And if you're feeling like this is a bit of work, I know it's a lot of work. I'm telling you, the lab itself will not take you very long. So you're going to take that F minus and you're going to write out the reaction. It's the same reaction that you wrote up above, and you're going to do an ice chart for it. Notice that here's where it says the molarity right here. This is 0.10. Notice that the number isn't the same for all of them. That's 0.18. But the ice chart will have the same setup where you're making x's. Then you're going to actually solve for x in this column right here. So notice we have our product over our reactant, and we have it equal to our KB. So make sure you do actually grab the correct K. You're grabbing it from the previous column. And then you're solving through till you get it. Make sure you pay attention to what you're getting. I would write what it is. A lot of times I like to write it over here also as a reminder to myself. And then finally, I'm doing the pH. pH is the negative log of, notice I've got this number in here. pOH is equal to that, which is pH. Notice that all of this is good practice, not only for solving for a salt pH, but it's also really great practice for solving for a weak acid because it's a similar process. When you look at the homework, you will actually probably see some similar compounds that you're figuring out the K. So in a way, too, the lab is helping you spell out with the correct format a good portion of the homework for this section, too. Hopefully that makes sense.